Yeah, good morning, my dear students. Today I am going to discuss about measures of variation, one of the important topic in data analytics and visualization. Before going to enter into this particular session, we will try to understand what are the different kinds of objectives we are planning to achieve at the end of this particular session. The objectives are like this: to understand different types of measures of variability. Next, we are enabling the comparison of two or more distributions with regard to the variability. Next, to understand measures of variability as a greater importance, other statistical analysis. With these objectives, we are proceeding forward, and finally we are going to achieve these outcomes at the end of the session. Student can able to define measures of variability. Student can able to describe different types of techniques that are used to measure the measures of variability, and student can able to summarize importance of measures of variability in the statistical analysis for solving different kinds of real world problems. So first let me create a context for this particular topic. Why measures of variability important? In order to understand that, let us see this particular scenario. Here I was given a small example. Here if you see, we are having a data set. Set 1 consists of various scores like 40, 50, 60, like that. Certain set of scores are given. Set 2 also given certain set of scores. So here what is the commonality is the mean of these two sets is same, that is 50. Set 1 mean is 50 and set 2 mean is 50. So what is the difference between these two sets means? If you observe set 1, here the distribution of this, assume that this particular blue line is the mean value and other points in this particular data set are distributed like this. Means we need to observe the distance between a point to the mean. In the first set, almost every point is almost close to the mean, right? You observe this thing only. When we are plotting this particular data set in a two-dimensional space, first we have identified the mean value of the data set and we are projecting the different points in that particular set towards the mean. So if you observe data set 1, we are finding that every point almost close to the data mean. Coming to second data set, this is our mean value. Second data set, this is our mean value, and see the points, one point projected here, other point projected here, like this the distribution was spread across. It means dispersion of or spread of this particular data set is more when compared to this particular data set. Okay, so what is the impact of spread? Finally, if you see, we are going for data analytics in order to extract some valuable information out of the data set. That valuable information may help to make some kind of predictions, or the valuable information may help in the decision making process. So here, what is the impact of spread in finding the insight of the data set or in making the predictions? So for example, for making you people to better understand, assume that these are the different stock prices. Okay, if I want to predict stock price of next day or next unit, if the data is in a pattern or data is in a some kind of serializable, then we can very easily able to make the predictions. But in this second case, if you see, one day stock price is this much high, other day stock price come down, and other day stock price is here, so data was spread across. It is a clear indication of inconsistency. Okay, based on this particular data set, we need to choose the algorithms that are going to make the predictions. So spread is one kind of important input to the data analyst. Based upon the data spread, you need to choose the algorithms in order to take some analysis or some predictions or any other kind of further process you want to perform on the data set. Spread is one of the primary input. Spread is one of the primary input. What will happen means, just in stock market example, if you see here, when spread is more, lot of diversity is there, then prediction will be very much difficult. Drawing a conclusion is difficult. So here that is the point of this particular topic. We are going to find out, first we are going to find out the spread of the data set. We are going to find out the spread of the data set. Okay, we are going to find out the spread of the data set. Once you find out the spread of the data set, then we can understand what type of data is underlying in our data set, and accordingly we can able to select different kinds of algorithms. So next we will try to see what are the different kinds of we will see what is meant by measures of variation. Then we will see what are the different kinds of techniques we are having in order to measure the measures of the variation. So measures of variation is a statistical tool. It is used to understand dispersion or spread or variability within a data set. Just now we have discussed, it is a statistical tool which will help us to understand dispersion, spread or variability within the data set. So they help in assessing how much the value in a data set differ from each other. So if you see here, 3 samples are there. Sample 1, these are the call durations of different set of people. 3 samples we have given here, sample 1, sample 2 and sample 3. The spread of sample 1 represented in a blue color, so it was spread, the spread is very high. So it was spread from here to here, this much spread is there. Some people use it for very low minutes of time, some people use it for very high minutes of time. So in this particular sample the spread is very high. Next, if you go for sample B, which was representing in green color, the spread of this particular sample is this much. Okay, when compared to the previous one, here the spread is little less. Okay, coming to the sample C, the spread of the data is from 150 to 250 minutes. Okay, so this is a representation of the data in a two-dimensional space in order to understand what is, how a particular sample spread out. Again I am repeating, spread is one clear indication to understand the data and to select the nature of algorithms for further processing. So with this we will proceed forward to understand, means here diagrammatically we are seeing there should be some mechanism which can able to quantify the spread and which can able to quantify, and that quantifying value should tell the significance of the underlying data set towards the spread. So here there are various kinds of measures, or we can call it as a tools, that are helpful in order to find out spread of the data or dispersion of the data, or we can find in a available data sets. So these are the different kinds of methods. Range is one of the method in order to find out spread of the data set, like that quartile deviation, mean deviation, variance, standard deviation. These are the different kinds of methods we are having in order to find out measure of variation. Measure of variation, what it tells, how your data spread across, right? So in these methods are broadly classified into two things, two kinds. One is absolute measures and another one is relative measures. Okay, all the purpose of these methods is to identify measure of variation, how data spread, how was dispersion of the data happen in our data set. So it is a kind of statistical means descriptive statistics which will help initial exploration of the data. That initial exploration definitely helps to go further processing by choosing good algorithms and making some kind of pre-processing over the data set in order to normalize the data. Here the point, one more point we need to understand, as I mentioned, there are two sets of methods. Relative measures. Relative measures also various types of tools are there. One is relative range, coefficient of quartile deviation, coefficient of mean deviation, coefficient of variation and standard scores. These are the set of methods or tools we are using in order to find out measure of variation. So these are the two broader classifications. Why two required? Why can't we proceed with absolute measure? What is the difference? A relative measure adding to the absolute measure in order to find out the spread. Here it was. Absolute measures focus on the direct differences, means direct differences between values. Direct differences between values means with the original data only it will consider in finding the direct differences. While relative measures normalize these differences. First it is going to normalize these differences by comparing them to the other characteristics of the data. Okay, other characteristics of the data like mean is one characteristic. It is going to compare other characteristics of the data. That is the difference between absolute measures and relative measures, which are going to use to find out measure of variation. So we will see technique by method by method how it works. So first method or first tool is range. The range is the simplest measure of variation and is calculating the differences between maximum and minimum value in a data set. So what will happen? It provides a basic understanding how spread out the data is. So the formula for calculating the range is maximum value in the data set minus minimum value in the data set. So the procedure is simple steps here I was given. First identify the maximum value in our data set, then identify the minimum value in the data set, then subtract maximum value from the minimum value, then we are going to get the range. So we will see simple this particular tool with a simple example. See here I was taken an example, different scores are given 78, 85, 92, 64, 97, these are the different scores. So now I am going to calculate a range of this particular data set. In the process, as I mentioned, first I am identifying maximum value, then I am identifying minimum value. The difference between this maximum value and minimum value, we got 33. So the range value is 33. What is the significance of this particular value? By looking into this value, what you need to understand, that is the important thing. Here you understand that range is one of the tool in order to identify measure of variation. Next, the formula for finding out the range is maximum value minus minimum value. Then we have seen an example in order to calculate the range. As per this particular example, we got a range value 33. What is the significance of this particular value? How we can understand? Suppose I got 98, I got 2 only, I got 3 only. What is the significance of that value in the context of variation? So here I was given high range value typically indicates greater variability. When the range value is high, then we can say that variability is more. Suppose range value is 2, okay, variability is less. Suppose range value is 95, then variability is high. Like that, depends upon the value of the range, we can able to understand what is the variability underlying data set is having. So this is one of the tool. So what is the problem with the range? By using this particular technique alone we can proceed forward, or it is suffering with any other disadvantages? Yes, range is sensitive towards outliers. As I mentioned, range is very much sensitive towards outliers. At this point you need to understand what is an outlier. When outlier is coming, then range value directly impacted by that outlier. So dear students, I will try to explain you what is meant by an outlier. Maybe in your previous sessions when we are dealing with data pre-processing, maybe you came across about outliers. So I will try to add furthermore in order to understand outliers. But this particular topic outlier we are going to use in many contexts, so it is very important. Further we will take a simple scenario in order to understand what is meant by outlier. So during the COVID season, when students are entering into our campus, their temperature was captured at the gate. Student 1 came and his temperature recorded as 90 degrees. And student 2 entered the gate and his temperature was recorded as 92. Student 3 came, suddenly something happened to the machine and it was captured his temperature as 500. After that it became okay and temperature recorded as 96. Okay, this particular value, if I want to find out the range, so here maximum value is 500, minimum value is 92, then I am getting a bigger value. Because of what? Outlier. When outliers are there in your data set, means a value which is not exhibiting common characteristics when compared to other values in the data set. In this particular context, 4 students are there, their temperature, remaining 3 students' temperatures are in 90s, but 1 student temperature is in 500 degrees. Maybe any arbitrary reason, maybe device malfunctioning. In this particular context, device malfunctioning. Because of device malfunctioning, a student temperature captured as a 500 degrees and it was stored in the database. When I want to do some kind of analysis, then this particular larger value, which is going to call as outlier, giving me wrong results, So I hope you understand. I hope you understand what is an outlier and what are the real-time causes for getting the outliers in our data set. One cause, as I mentioned, device malfunctioning, typographical mistake. Any arbitrary reason may be the cause for generating the outliers in the data set. When outlier is there, this range method will fail in order to identify the variation. When outlier is there, we are getting a variation around 300 plus. By looking into that value, we can understand that variation is very high, but it is not correct. Variation is low, but because one single value creating that kind of results. Okay, I hope you understand. Coming to this particular technique or statistical tool range, which is used to find out variability failing when it is encountering outliers, right? This is one technique. We will proceed with the other technique. Quartile deviation. This is another kind of statistical tool we are having in order to measure spread or dispersion in the data set. Here we are going to find out spread or dispersion around the median. I hope you know what is meant by median. Median is the middle value. When it is going to compare everything with the median, and it is going to find out. So here first we will before understanding quartile deviation, first we will try to understand what is meant by quartile, then how to calculate quartiles, then we will see what is the how to calculate quartile deviation in order to find out spread in the data set. So data in the process of understanding quartile, in quartile data is divided into 4 different components, 4 different parts. First 25%, 50%, 75%, 100%. 4 different parts data is divided. Okay, and see we will see the procedure for calculating the quartiles. So this again we will go back. First we will see what is the procedure for calculating the quartile. First thing, you need to arrange the data set in ascending order. Whatever the data set, whatever the size of data set you are having, first arrange the data set in a ascending order. Second step, identify the median of the data set. How to identify the median of the data set? If the data set is having odd number of values, okay, then median is middle number, Odd number of values, suppose for example if you see 1, 2, 7, 11, 9, okay, 1, 2, 7, 11, 9, these are the odd numbers, means total count is 5. So what is the median? Middle number directly will become the median. If on other hand we are having even number of values, median, how to calculate median? Average of 2 middle numbers. Suppose we will add one more number here, 12. These are the 2 middle numbers. 7 plus 11, 18 by 2, 9 is the median in this particular context. So like this we need to calculate median. First we need to arrange the data items in ascending order, then calculate the median. Then how to calculate Q1, quarter 1 or quartile 1. So this particular quartile 1 we need to calculate from the data set. First we are going to point out below, 25 percentile of the data. What it means is the point below which 25% of the data is falling. Suppose quartile value coming 15, okay, it indicates that the 25% of the data fallen below this particular value. 25% of the data fallen this particular value. So in order to find out Q1, what we need to do means, okay, consider the lower half of the data set. Okay, suppose this is the middle one, this particular part is lower half. Consider the lower half of the data set. If the lower half of the data set having odd number of values, Q1 is median of the lower half. Okay, if the lower half has even number of values, Q1 is the average of the middle numbers. Like this, we are going to calculate the first quartile. Already second quartile is median. This is the first quartile we have calculated. Then third quartile. It is simple. You just take, okay, you just take upper half of the data set. Upper half of the data set. Data set is divided with the median, and when we are going to calculate Q1, come to the left half. When we are going to calculate Q3, go to the right half. In the right half, same procedure. If upper half having odd number of values, Q3 is the median. On the other hand, if the upper half is having even number of values, Q3 is the average numbers. Like this, we are going to calculate different quarters, Q1, Q2, Q3 in our data set. Right. Then after calculating the Q1, Q2, Q3, the different quarters from our data set, our tool quartile deviation. What is the formula for calculating quartile deviation? This is the formula. Okay, this is the formula for calculating the quartile deviation. Q3 minus Q1 by 2. Okay, Q3 minus Q1 by 2. So we are going to compute Q3 minus Q1 by 2. Based upon the value, we can tell the spread or dispersion of the data set. For that, we have given an example in this. In this example, we have calculated quartile deviation. We got around 11.5. If more deviation is there, then we can say more variation in the data set. It's a simple steps. The example was given, and we are finding out the quartile deviation. Next type of statistical tool, mean deviation. Mean deviation is other kind of statistical tool. As I mentioned, all these tools are different approaches in order to find out variation or spread or dispersion in the data set. In that process, mean deviation also other tool. What it is going to do, it is going to find out average deviation. Okay, so what is the thing we are going to find out means mean and median difference is mean is going to find out average value of that particular data set. Okay, average value of that particular data set. So what is the formula for calculating mean deviation? In order to calculate the mean deviation, this is the formula: summation of, okay, summation of absolute x minus mu by n. Here mu is the mean value, n is the number of samples, and x is the data item. Okay, here x is the data item. X minus mu, it is what it represents. It represents absolute difference between data point x and the mean value mu. It is going to find out absolute difference between data point x and mean value mu. And n is represents number of samples. So we will see. It's a very simple thing. How to calculate mean deviation means mean deviation. Calculate the average of the data set. For each data point, find the absolute difference between data point and mean value, and we need to perform summation of those differences and divide that one with number of samples. Then we are going to get mean deviation. What mean deviation is telling means how rest of the data deviated from the mean value. This particular value tells us how rest of the data deviated from mean value. Suppose in a class, assume that the height of the students was taken. The height of the student is 5.2. Okay, some students are 7 feet, some students are 4 feet. So the mean deviation tells us how other students are deviated from the mean value. So that clearly indicates the variation or spread in the data set. So here an example was given. See, this is the data set we have taken. First we have find out the mean, we got 88.2. Then we have calculated absolute difference between mean and data points. These are the different values we got, and after that we are performing the summation. We got 21.2 summation. So as per the mean deviation formula, this is the formula for mean deviation. 21.2, total samples are 5. So we got a value 4.24. Okay. So here what is the significance of this particular value? A higher mean deviation indicates greater spread. higher mean deviation indicates greater spread or variability in the data set, while a lower mean deviation suggests that data points are close to the mean. When data points are close to the mean, they are consistent and making predictions or taking decisions based upon analytics are very much accurate. Okay, so that is the point we need to understand about mean deviation. Next kind of tool is variance. Okay, we have done with mean deviation. Next kind of tool is variance. It is a statistical measure, as usual, used to find out spread or dispersion of a set of data points in the data set. It quantifies how much individual data point deviate from the mean. Means a numerical value it generates, and it tells that how it was deviated from the mean value in the data set. Okay, the formula for calculating variance, this is going to calculate the variance here, summation of x minus mu whole square by n. Here summation of x minus mu whole square by n. Here x minus mu represents the difference between data point x and mean value. It's not absolute difference. Earlier when we are going to deal with mean deviation, we are going to concentrate on absolute deviation, but here we are going to deal with the difference between data point and mean. Okay, we are squaring this particular one, represent the square difference between each data point and the mean. If you are squaring, then what happen means we are going to concentrate on negative values also. When we are dealing with absolute value, we are not going to concentrate on direction of the spread. Here we can able to include direction of the spread also. That is the difference between mean and variance. So simple steps for understanding how variance getting calculated. First, calculate the mean of the data set. For each point, find out the square difference between the data point and the mean. Then sum of all these square differences divided by n. N is number of instances in that particular data set. That gives variance of the data set. So here, as I mentioned, handling negative values not happening in mean deviation. Considers only absolute differences, ignoring the direction of the deviation. Okay, both in the variance, what happened? Both positive and negative deviations, as a squaring them removes the sign. So we are going to consider both positive and negative deviations. That is the main difference between mean deviation and variance. Variance is considering the direction of the deviation also. Next, standard deviation. Standard deviation also almost looks same, one of the other statistical tool in order to find out dispersion of the data in the data set. It quantifies how individual data points deviate from the mean of the data set. Standard deviation is more interpretable measure than variance. Okay, why? Because here standard deviation, we are calculating square root of the variance. Standard deviation is nothing but square root of the variance. Here, see, this is the formula for calculating the standard deviation. So these are the, already we are familiar with these notations. Summation, difference between data point x and mean, excuse me, and we are calculating the score of this, and finally we are finding out the square root of this. This is standard deviation, and these are the set of steps or procedure for calculating standard deviation. First, we need to calculate the average of the data set. For each data point, find the square differences between the data point and the mean. Sum up all these square differences divided by total number of instances in that particular data set. Then take the square root of this result to obtain the standard deviation. So standard deviation provides insight into the spread or dispersion of the data set. As I mentioned, a larger standard deviation indicates that data points are more spread out from the mean, suggest greater variability in the data set. Means what? We are going to calculate standard deviation, and we are telling that how other data points are deviating from this particular standard deviation. Okay, so depends upon the value. If value is more, then we can say more variability is there in the data set, and less means less variability is there in the data set. So these are the different kinds of tools we are having in our data sets in order to find out spread or dispersion. As I mentioned, we are having different kinds of tools: standard deviation, variance, range, mean deviation, quartile deviation. These are the different kinds of tools we are having. In the next session, we will see about relative ranges.